Okay, if we look at these expressions, did you notice any that are obviously not polynomials? 2 is not a polynomial. How come? It has a negative exponent. In fact, it has 2 of them. Now, when we say negative exponent, we mean negative exponents on variables. You can have whatever exponent you want on a number. That will not affect being a polynomial or not being a polynomial. So we only look at variables. None of the numbers will change the fact that it's a polynomial unless it's an exponent. So you're only looking at exponents on variables. Okay, any others that are obviously not a polynomial? Why is 8 not? It has a fraction exponent. That 3/4 is against the rules. Okay? You would say not polynomial and circle Y. Okay, is number 1 a polynomial? Yeah. Number 1 is. What about 3? Look carefully. You cannot have a variable as an exponent. So number 3 is a no because of that x in the exponent. What about number 4? Well, if you look closely at that definition that was on page 3, it says no square roots of variables, no fractional powers, and no variables in the denominator of any fractions. So, oh, I moved that. So 4 is a no because of that x. What else? 6 is gone because there are a whole bunch of x's in the denominator. So that leaves 5, 1, 5, and 8 are all polynomials. 1, 5, and 7, thank you. 8 is not. 1, 5, and 7 are all polynomials. Okay? So basically, as long as you have x to the 4th, x to the 3rd, x squared, x, and you can skip numbers, but nothing crazy can happen in the exponents. No negatives, no fractions, no square roots, no x's in the denominator, then it's considered a polynomial. And you don't really understand why polynomials are terribly important, and I didn't understand until I made it a lot further in mathematics. And I realized that you can turn almost any real-world situation into a polynomial, and once it's in polynomial form, the math is a lot easier. So that probably doesn't help much. Okay. Now, for number 9, we have 4 versions of the exact same polynomial, and each version means something different. So the first one is called an expression, which means it has no equal sign. And it's just some variables and numbers put together. It doesn't have a lot of meaning in that form. Okay? The second one is y equals. This is the equation of a graph or a curve. So this is a graph or a curve. So for those of you with calculators, turn your calculator on. Megan, you're on your own with that thing. I don't know how to work it. It's an Inspire, and I don't like Inspires. I might be able to figure out today, but after today, I don't know. So turn your calculators on, and you're going to push y equals. Whatever's in there, if there is something, just clear it out. And then type in everything after the equal sign. And the x's are right here next to the alpha button. You see x, t, theta, n. that button is always used as a variable. So we'll do x squared minus 3x plus 3. So type that in. Did you get it? Oh, you guys are way ahead of me. Pull yours out. We can get it figured out. All right, once you have that, just push graph. And my settings are off a little bit, so I need to go back to Zoom Standard. So I have a graph, a parabola. So you studied parabolas last year. Oh boy. This graph, this curve is the graph of x squared minus 3x plus 3. Now I want to highlight the difference between numbers 10 and 11. 10 says y equals, which means that the graph is everywhere that is shown. Every single y that's possible in that graph is valid. Oh, well, this is kind of a mistake. When it says 0 equals, you're only looking at the values where y equals 0. Now, I've made a mistake on this because it was supposed to touch the x-axis, but it doesn't. So let's suppose that the graph actually does touch the x-axis. If I replace that y with a 0, I ignore the entire graph except where it touches the x-axis. So in number 10, the entire curve is the equation. But in number 11, we ignore the curve and we only look at where it touches the x-axis. Now these places have 3 names. Anybody remember from last year what they're called? They intersect the x-axis. That's usually not how we talk about them. Let me give you some hints. Roots. That's one. Zeros. And the other is called a solution. And all 3 of them mean the same thing. Okay? And in number 12, f of x equals x squared minus 3x plus 3. This is just function notation. So this is a function, which means for every input you only have one output. Now, you can actually transition between any 4 of these representations because it's the same polynomial. If you want to look at the graph of a function, you just take this f of x and you replace it with a y, and then you can graph it. If you want to know the roots of the polynomial, you take the y and you turn it into a 0. If you're just looking to factor the polynomial, you can drop the y or the f of x entirely and just look at the answer of the factor of number 9. Okay? So it's the same polynomial. There are just 4 different ways to represent it. Okay. Now here's where you guys that don't have calculators are going to be in a little bit of trouble. Use your graphing calculator to determine the zeros and the factors of each polynomial below. So yesterday we looked at a polynomial and we factored it and we found the roots. Today we're going to look at a polynomial and find the roots and then create the factors. So I'm going to take 4x minus 32. Oops, wrong. So in my y equals, clear that out, 4x minus 32. Graph it. And the roots are where the graph crosses the x-axis. Where does this graph cross the x-axis? at 8. So the answer is x equals 8. That is the root. What is the factor associated with that root? So 4 times 8 so if I factor this 4x minus 32, what can I pull out? A 4, so we get 4 times x, sorry, minus 8. So this is the root, and this is the factor. So yesterday, we looked at the polynomial, we created the factors, and we found the roots. Today, we're going to use the calculator to find the roots, and then just for practice, we're also going to look at the factors. So how do I transition from root to factor? How would you convert a root into a factor? It's really easy. So put an equal beside it, inside of it, and switch the sign. That's it. Okay? Okay, for number 14, let's graph number 14. X squared minus 6x minus 27. Graph it. So my roots are x equals -3 and 9. So what are my two factors? X plus 3 and x minus 9. So I'm just going backwards from yesterday. Yesterday we used the polynomial, then found the factors, then did the roots. I'll tell you in a second. Okay, and notice in number 13 I had a y equals. In number 15 I don't have anything. But that polynomial still has roots. I'm just going to plug this in my calculator and graph it. And then find the roots. So your assignment today is to finish the rest of that and the entire back side. Some of them end up having 3 roots. And sometimes the roots are so big they don't fit on the calculator screen, so you need to change the calculator screen. Good. What if a polynomial does not touch the x-axis? It's a function, and it has roots, but they're imaginary. The calculator will not calculate imaginary roots. You need a different method to find those. And so just say no real roots. It has them, they're just imaginary. That's a good question.